Okay, so we are at problem LeetCode 198, house robber. We are professional robbers planning to rob houses along the street. Each house has a certain amount of money. So let's think of an array of houses, and in each item of the array, we just have an integer of what is the amount that we can rob. So basically, we need to rob the max amount of money from this array of houses. We have a constraint. The constraint is that we cannot rob two adjacent houses. Okay. So given an integer array of nums representing the amount of money for each house, return the maximum amount of money that we can rob without alerting the police, meaning that we cannot rob both 1 and 2, only maybe 1 and 3. We cannot 2 and 3, only 2 and 1. So let's look at this problem. Let's write here this array. So we have 1, 2, 3, and 1 again. So let's start robbing this according to the guidelines. Okay, so we can decide to rob this. So we would have here 1 as the max. Okay, or if we don't rob this, then we would have a 2 here. Okay, and now let's jump to this place. To this place, we need to look at the previous maxes so far. Okay, so we see that if we robbed 1, we can add 1. So here we can have 4, but if we robbed 2, we cannot add this, so we would add only 1. Okay, so we would add only 1 plus 1 plus 1. This was plus 3. And the max is 4. Okay, yes, the max indeed appears to be 4. Now the array can be really large, so it can appear complex, and I think the solution to this is quite ingenious. So let's go over the solution, but it relies on a pattern that we have already mentioned, because if we look at this problem again, then we have a list of numbers, right? And basically, if we use the so far pattern, then we can see that if we have here the so far, let's call this so far prev. This is too long. Just call it A and B. A and B. Max so far until this place and max so far until this place. Then here we can say that the max so far here would be either the max so far of A plus this number or the max so far of B. Okay, so we are reducing the problem. And here, what would be here? The max so far. The so far pattern, max so far. It would be either this number plus this current or just this one. Okay, because we are reducing it. And note that we don't take this previous and add to it the next number, the current plus 1, because we always like to simplify the problems. Okay, so we are using the so far pattern, and we say that the current max, or the current so far, current so far is either the prev so far plus current, or just the prev so far, because we cannot add the current to the prev so far. Okay, so with that understanding, let's begin solving this. Okay, let's go over here to the code. Yes, this would be the code. Okay, so this is in Java, and we begin writing it. So we said that we have the max so far prev and the max so far until the previous item. So let's name them. Max so far prev is starting with 0. Also, max so far. Note that we didn't even use recursion. This is the geniusity of this solution. And we scan each item, the current, each item, and then we say exactly what we said in the algorithm. What is the new max so far for this current item? Okay, so new max so far for this current item. It's going to be either the previous max so far plus the current item, the previous one, not the one adjacent, but the previous. So the max so far prev plus the current value, or just the max so far, just the one before, the max before. Okay, and now we are going to say that the max so far prev has proceeded to the max so far. Max so far prev is now the max so far, and the max so far is the new max so far. Genius. Okay. And now we return the max so far. So I have to show this again because this is really, I think, a genius solution. So basically what we are saying is this. We have this array. Let's scan item by item. And now let's say this is the current item, the current value. We had calculated the max so far prev here, max prev here, and this is the max so far. Now what is the max so far here? It's going to be either the max so far prev plus the current value, or just the previous max if it was larger than this one. So this is the max that we did here. And now that we are progressing to here, we are saying this is now the max so far, and this is becoming the max so far prev. So we are progressing it. This is exactly what we did in this solution. We said for each item, what is the new max so far? First, it's going to be the maximum of the so far prev plus the current and the max so far. And now the max so far prev is progressing to be the max so far, and the max so far is the new max so far. Confusing and genius, but this is what we have, unfortunately. This is our job. Okay, so now run the code. Looks good, accepted. And now let's submit this. And yes, looks very good. Okay, so this was a problem 198, house order with max so far pattern.